let me do an example like this. I don't want to do that exact problem. Now listen to me. This is number 24, right? 24? In section 2.3. Yeah. But both A and B are the same idea. They don't ask you to find a percentile, like a specific percentile. They ask you to find what percentile is this data point in. So, for example, if I had a list of data, oh man, I can't deal with all this specks of shit up here. Get out of here. I didn't used to be so. All right. So let's say I have this data here. Write this down. Let me just plop some numbers down so we can talk about it. All right, and I say, what percentile is 38? I really want this to make sense. There's a formula in the book that for really small samples, it's too much. And for really big samples, it's not necessary. But they put it in there because some statisticians use it. So this is what's really weird for stat students. You guys don't get to see the entire picture of this. But statistics is a field of mathematics that's still being ironed out. Not at this level normally, but percentile is one where there's some disagreement about how to measure it precisely. And then there's people like me that say the idea isn't really a precise idea in the first place. So I don't need this crazy ass. If you look at the formula they use, I don't know if anybody's used the formula for this problem or if you just copied out of the solution manual. The second thing is bad idea. Right? I love it when people copy stuff they don't understand. So you end up copying things in a weird way. And I'm like, all right, you don't know what you're doing. All right. Make it a challenge for me. So what percentile is 38? What was the idea of a percentile? What's the idea? What the 80th percentile means what? 80% of the data is below that. So what's a very basic way to get an estimate for what percentile 38 is in? Well, I could take a look and see what makes sense to go along with the idea. If I yeah, sort of what place, but more specifically then how much data points there are, how many data points there are below it. So I want to use right grammar. So 1, 2, 3, 4, 5, 6 data points below it out of how many data points total? Out of 11, right? I think it's 11, right? Okay, I like it. Now there could be some argument as to should I include this or not. But for small sample set sizes, for small samples, percentiles don't have to be that precise. And for big samples, they will be precise if you do the same method. Now, if you'd rather just use the formula in the book, you can plug the stuff in there. It takes into account repeats and stuff like that. But what is 6 divided by 11? 5, 4, 5, 2? Right. Yeah, 5, 4, 5, 4, 5, 4. Okay. So it's 54.5 roughly percent, we'll say approximately. Guess semi, sort of, kind of, not really. So now watch, stay with me. Let's check this. Let's around this even more, because we normally don't see percentiles this precise. Because the idea of a percentile is not really precise, to be honest. How would I find the 55th percentile of this data? I would take, so what would P55 be? I would take 0.55, 55% of 11. And what's 0.55 times 11? 6.05. What would I do with that 6.05? Round it to 7. And what's the 7th number? 1, 2, 3, 4, 5, 6. Holy shit, it's the frickin' 38. I mean, so do you see what I just checked my answer? My answer for what percentile is 38 is the 55th percentile. And then I just went and did the work to see what it would be. What's the 55th percentile? And I got frickin' 38. Okay, maybe. So yes, that 24, we didn't do that specifically but it's the reverse of what we did do. I was using the idea. Now listen, you guys stay with me. What's most important in mathematics is the idea behind something we do, not the something we do. So what's the idea of percentile? The percentage of data points that are below some data point. So then I use that idea in any which way they ask me, because that's the idea of it. So maybe, you guys all right? Yes?
So anytime you get like a percentile that's the decimal in it, you want us to like round it?
You always force it up and take that number.
Oh.
Yep. Okay, maybe. But again, there's a formula in the book, and if you want to use it, you can, and blah, blah, blah. Okay, maybe. You've never heard a math person talking about a formula like that, but... All right. You're at the level now where we can talk more openly about stuff, because when you're in algebra, you are learning basic processes. You aren't talking about when those processes are the best way to do something, because you're just learning them. Once you know them, you can start going, well, it's not always best to do that shit. Sometimes it's better to do this shit. All right, then you do that shit. So when I teach like Math 120, Math 120 is a place where you could use algebra if it makes the most sense. But whatever makes the most sense is what you do. And that's what students love it. And I'm like, well, that's because this is an algebra class. In algebra class, you got to use algebra, right? Where in statistics, we can use it if it makes sense. Okay, maybe. Anything else from homework? Yes? Or...
I just have a question. How did you get, like, remind me again, how did you get 6? Or the fraction 6 over 11? I think I got 11.
So remember, what's the basic idea of percentile? Is the percentage of data points that are below that data point.
Yeah.
So then I just counted 1, 2, 3, 4, 5, 6 below 38. 6 data points below 38 out of 11 total. Okay, I like it. Maybe. So that's all you got to do for that problem. You don't have to use the book's formula. You with me? You can if you want to. It's great. It works. It's just too much. Okay, maybe. Anything else from homework stuff for you guys? Yes?
Number 82.
Number 82? Oh, good. Okay, so there was a problem like this earlier in the book where you just have to think about the situation, right? And this, I'm sure, how are you guys feeling about statistics so far? Now, chapter 1 is rife with definitions. Too bad. You just got to put up with it. We got to both know what each other's talking about, so you got to do that. But there's a lot of questions, even when you get into the math section, there will always be conceptual questions that make you step outside of statistics. Because what's statistics for? Everything in the universe uses statistics, right? Believe it or not. So this problem, I don't know if everybody's tried this one yet, but it says here the median age for U.S. blacks currently is 30.9 years. For U.S. whites, it is 42.3 years. Now on the surface, you can already start thinking about why there would be a difference. So that's really what it talks about. So median for U.S. blacks is 30.9 years. The age for U.S. whites is 42.3 years. So what would make, let me break this down without talking directly about that. Let me just show you some numbers. If these were kids, there's more younger kids than older, right? So right now, what's the median age? You kind of do this into such a small. All right, do. So the median age is 2. How can I make that median go down? There's 2 ways. So you can kill people and you can let people be born. And that's the 2 things you could do with people, right? And obviously there's a lot, but basically either they living or they ain't. So you can make them stop living or you can make them start living. Are you with me? So we are God for this problem, right? Or, whatever deity is your favorite. How could I make the median age? It's pretty cool. In fact, we haven't talked about median yet. So this is from that section. But the median is the same thing as P50. The median is the number that's in the middle of the data. And P50 would be halfway through the data. You like it? How can I make that go down, decrease? There's two ways I can do it. Why was it so low to begin with? There's more younger, right? So how can I make it go even lower? Make some more younger. I could have somebody just born. Now what's the median age going to be? Bam, 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 bam. It's still 2. Have another one just born. Now it's 1.5. So if you have more lower numbers, it's going to pull the median down. What's another way to do it?
Take out the bigger numbers.
Yeah, this is where we get really sadistic. Sorry. We're going to kill this guy. Yeah, Dad. All right. Now the median could go down, and if I kill this guy too, the median is definitely going to go down. Do you guys see how that relates to this problem? Why might the median age for one group of people be lower than another? 2 reasons. They either have more or less. And those are 2 different things, aren't they? Okay, that's all I'm going to do for that one. So that was number 82 in section 2.3. I like it. Because if you just read through that, you're like, I don't know. You got to kind of think about how would you affect that median? How would you make that move? And then how does that relate to the actual physical problem? Okay, anything else from homework stuff? All right, good, because we got a lot to do. Did I bring those with me? Probably not. That's fine. So we still have to talk about measures of center and then measures of spread. So when I told you the quiz averages, I gave you the average grade and I told you the spread number. So for example, let me just tell you why spread would be something good to eventually know. Do you guys know about Rate My Professors, of course, right? Okay, I love it. I remember when I was working on the East Coast and the faculty first heard about it, like a lot of my colleagues went and rated themselves. And you go in, you could tell this one guy, he's the essence of the essence. I'll never forget that shit. I'm like, really? It's this one philosophy teacher, and sounded just like him. Yeah, good job. If you don't know about Rate My Professor, that might be better. I like to tell my students, it's nice to get good reviews, but some students I want to get bad reviews from them because it tells me I'm doing the right thing. Anyway, there's also another website that people don't know about, and it costs some money, thankfully, to get onto it, but it tells you grade distributions for every professor, because that's public domain knowledge. You could actually call Grossman up and request grade distribution data, just so you know, right? So let's say that we're at university, all right? Because what happens at university? What's passing at a university or a college, like not a community college? Here you got to get a what for it to transfer? C. And once you get to a 4-year college or university, what do you have to get to pass? Do you guys know? A D passes. A D is passing. D minus is passing. So think about that next time you're driving across the bridge and you're wondering, which engineer made this sucker? Hopefully it wasn't that D one. Tell you what. Anyway. Just keep that in mind. So we're at university or 4-year college, so a D is passing, and let's say that there are 2 teachers. I could take either one. They're both like the same. They're like clones of each other, except one teacher gives, and they both give an average of a C. So with that information alone, I'm just gonna like flip a coin or something, right? But what if I told you something else? One teacher only gives B's through D's. And the other teacher only gives A's through, they give everything. Not only. A's through F's. Now depending on the class, like if it's a class you know is going to be really hard, who would you take? If it's going to be really hard and you're worried you're going to fail, you probably take the one that doesn't give out any F's. You take the B through D one, right? Whereas, if you know you're going to kick ass in this course, you are never going to take the B through D, Because if you kick ass, they don't give out A's. And I had a teacher like this, and I'll never forget this guy. I got the highest grade. I got a B. Sorry. He was waiting for some deity to come, and then they would get an A minus. Anyway, you guys kind of with me? So knowing the spread of the data is useful. Just knowing where the center is isn't enough information. So let's talk about how to find the center. There's multiple ways to do that, and then we'll talk about how to find the spread. Here's one way up here. So we'll start with the most basic way to find the center of data is the average, or what we call in statistics, we call it the mean. Measures the center. So we have the mean. How do you find the average of a group of data? Yes, I like it. Okay. So together we got it. Let me put it in English. Add them all up. Divided by how many there are. Right? You all know this. You all know this coming in. That's how you find the average of any group of numbers. Add them all up, divided by how many there are. This is going to be our first step into real formulas. So this is really important. Okay. So atom is going to be the symbol that. That's the summation symbol. Anybody know what letter that is? Sigma, I like it. So you go to a university or something, you want to join a fraternity, it could be Sigma, Sigma, Sigma. So they like to use Greek letters. Sort of the same reason Super Bowl likes to use Roman numerals is to make it more impressive, right? And of course, Super Bowl 50, the Roman numeral for that was L. So they have this big. I just was hoping somebody have a big rock L, just kind of Super Bowl L. But MCN blah blah is a lot more impressive, right? The Super Bowl XVI. Oh, sorry.
Who played that Super Bowl?
What's that?
Who played that Super Bowl?
50?
XVI. Or what's that?
XVI, dude. What would XVI be?
Oh.
60. 10, 5, 1. Anyway, sorry. You don't have to know Roman, sorry. Just Greek. That's all I got. This is sigma. It's the Greek letter S, and of course math people chose it because another name for add is sum. So we just chose the Greek letter S to be different. Right? And the Greeks are like, fine, whatever. So if I give you a group of data, what do I use to represent all of the data values? X. So add up. So this symbol right here doesn't really make sense by itself. Unless that's talking about like a letter. Sort of like if I said, okay, do the square root of, do it. Well, what would your question be? Square root of what, Jeff? Okay, shit. So the same way, sum doesn't mean anything unless there's something next to it. Sum up these. Whereas square root also doesn't mean anything unless there's something in it, right? I like it. Maybe. Sum them up divided by how many there are, and we're always going to use the same letter for that. The number of data points, we're going to use the letter N. Okay. Now, some of you guys are right now going, well, just like mathematics, take a simple idea, put a bunch of freaking Greek in there. What the shit's wrong with you, man? But this is just us getting used to these symbols. What math does is sort of like shorthand. It is a different language. That symbol means a phrase. That symbol means a phrase. That symbol means a phrase. I'd much rather write these symbols than that freaking phrase all the time. Even if you disagree with me, you're going to have to do it anyway. Nah. Now, I could have a mean of a population or a mean of a sample. And we actually use two different symbols just to communicate that real quick. For population stuff, it's going to be Greek letters for right now. So get ready. The population mean has the symbol mu. It's like a U with an extra leg. See that? It's a U with an extra leg. I know a lot of you guys are going to make it an M because it's freaking mean, Jeff. Why wouldn't I make it an M? But try not to. Try to make it a mu. So yes, it is. The Greek letter mu sounds like a French cow or something. I always think. Or whatever you want to put in there. Okay. Or don't think about it as an animal at all. I'm sorry if you don't want to do that. You don't have to. What about if it's a sample mean? We use the symbol x bar. And actually, the formula is the same. I think the book uses a capital N here, which is absolutely foolish. N just always means the number of data points you're looking at. Doesn't matter if you have a population or a sample. So I want to do a quick example real quick. I'm going to give you two sets of data. Let me see. I like it. Later this semester, we're going to look more deeply at this example, but this is X represents the number of drinks somebody had the night before, and Y is the grade they made on the 7 a.m. test the next morning. But I'm not going to get into the correlation between those two. That's for later. Right now, I'm just going to ask you, can you find the mean? Can you find, these are samples, by the way. It doesn't really matter, but I'll make it easier for me to distinguish. Can you find X bar? And can you find Y bar? Now, do you see why? This idea of putting a bar on top of something does mean average this. So if I have multiple sets of data, I can reference each one quickly. So just take a minute and figure out X bar and Y bar. And again, what does X bar mean? Sample mean for the X's, and Y bar means sample mean for the Y's. I love it. That's all you're doing. So what do you get here? Sum of X is 6. And how many? 4. And that is 3 halves, 1.5. Cool. How about Y bar? What's the sum of Y? 315? Of course, you pick something 4 doesn't go into, Jeff. What's that divided by 4? It's like 78.25. 75. Shit, I went the wrong way. 78.75. Neat. And that's Y bar. Kick ass. Okay. Nothing major, just getting used to the symbols with a very simple example. That's why I love that we do this mean first. We all know what the hell the mean is. Now we know what it looks like in statistics-ish. And it's still the same work we did before. I like it. But guess what? You got to do it. Yeah. Because I'm going to show you, obviously, how the calculator can do all this with a couple button strikes. But your work is not telling me what buttons you pressed. That is never your work. Calculator passes the course. They go meet somebody. They have a great life. Have little calculator babies. And you're taking the course again. Okay, so that's one way to measure the center is the mean. The other way to measure the center we already talked a little bit about. Got it. Is the median. And the median is really straightforward. It actually is P50, like we said earlier. It's the data point that's in the middle, just literally in the middle. The mean isn't really the data point that's in the middle. I want you to realize that. What's the, real quick, before we get to median, what's the average of 1, 1, 1, 1, 1, 1, 7? It wouldn't be in the middle of 1 and 7. It's going to be closer to 1, right? Don't even have to really calculate it. I know it's going to be closer to 1. The median, yeah. So for example, it's the number in the middle. What's got to be true about my data for this to make sense? When I do percentiles, the data has to be in a order, or else I can make it whatever the shit I want to. So let's say I'm looking at possibly starting to work at this company, and there's only 4 people that work there currently. They're hiring 1 more person, right? And right now there are 3 employees that make $31,000, $40,000, and $45,000, and then there's 1 CEO dude that makes $500,000 a year, right? So it's pretty well. Doesn't do a good job of explaining how things work for most companies, but because it would be much bigger. Get your policies out of here, Jeff. All right. If I ask somebody, how much could I expect to make if I work there, and they tell me the average, is that an honest assessment of how much I should expect when I start to work there as an employee? I'm not a CEO. I'm going to be just an employee. What is the average of those? Somebody take a minute, help me out. This little population of people, by the way, is going to use mu. Very small population of people working at this place. 154? Neat. So 154, everything's in thousands. Are you with me? So if I ask somebody, I don't know this information, and I just go to the HR and I say, how much could I expect to make? And they're like, well, the average is 154,000. I'm like, damn. All right. I can almost think about looking at a home in La Jolla. Not really. No, I can't. Think about getting a garage in La Jolla. What number should I tell this person to be more honest? The number that does not take into account the value of this. The mean takes into account every value, so outliers will always affect the mean. But what's the number that's in the middle? What's P50? What's the number in the middle? This is the symbol for it, by the way. Yeah, it's going to be the number in the middle of these two, right? 50% of 4 is 2. Take the second and third, average them. But you don't have to do that shit for 4 numbers. What's in the middle? The number that's in the middle of the 2 in the middle is in the frickin' middle. Well, that's a neat sentence. The middle of the middle is the middle. Shit. So yeah, it's going to be $42,500, right? 42.5. Let me just say 42.5. Everything's in thousands. So if I told this guy, yeah, about 43,000, that's much more honest. Don't get me all excited about the 154,000. Maybe? Yes?
Is that the symbol for the median?
Yes, this here is like the mean that had a rough night, right? This little hat got all crooked. Okay. All right. Or good night. I don't know. It depends on your own definition. When else would I use the median? I sort of gave it away just a minute ago. I don't know if, do you guys know that they still make newspapers and shit? You guys realize that? And yes, I get them. Yes, I do. And but even online and shit, I've heard on the internets that they have these. They show you like home prices and so forth, but they never tell you the average because that wouldn't make any sense. If I told you the average home price in La Jolla, isn't it going to be a little skewed up? Aren't there a lot of freaking very expensive places? Are they all very expensive? No. More expensive than I can. That's why I don't live in them. But if I gave the median, you always see the median home price because, again, if I have outliers in my data, the median will be a more accurate measure of center. See how slow I said that? See how important that is? See how good of a note that would be? When you have outliers in your data, The median is much more accurate measure center than the mean. Okay. Now, this is a little unfair because what kind of data have I completely looked at only? The two main types of data, the Qs. Remember the Qs? The two Qs. What kind of data have we looked at so far? We've only looked at quantitative data, right? We looked at numbers and shit. So there's got to be a measure center that works for any kind of data, if it's qualitative or quantitative, and there is. It works for both. And it's called the mode. Let's think about Depeche Mode. I think about either Depeche Mode or I think about high a la mode and I want ice cream. The mode is the number that occurs the most. Mode, most. So is there a mode here? Nope, no mode. I like it. So most of the ones that I think we've looked at has no mode. Number occurs most. So what about this example? What if I had, no, let's make it A there. 1, 2, 2, 3. What's the mode? Oh, okay. And I think one semester I actually had a student say something about this, because there's no symbol for mode. So we actually created a symbol for mode. And I don't know if you guys are like, I don't give a shit, Jeff. But what the hell? We can make math our own. They had made it like just a big M, I think it was mode. But we could be more creative. Or not, we don't have to. What about this set of data? 1, 1, 2, 2, 3. What do you think? Yes, it's bimodal. 1 and 2. Craziness. Yes.
So every time it has one means indicate that it's bimodal or
You don't actually have to say bimodal, to be honest. You can just say the modes are 1 and 2. That's beautiful, but I just want to let you know that there's a word for that. It's bimodal, which kind of makes sense. Like binomial. Oh shit. Not algebra. I'm sorry. Okay, what about this? Yeah, good. There's a winner. Don't just list everybody that has repeats. Mode is the number that occurs the most. This one's only got one mode. Unimodal. No, screw that. The mode is 3.